Well, good afternoon, everyone. I am Gabrielli de Almeida, first round PhD student, starting now my second day. I am Brazilian, and my main background is in material science and engineering. So our project involves ILL, ITQ, and CEPSA. From each one, I have a main supervisor: Mônica Jimenez Ruiz, Teresa Velasco, Fernando Rey, and Jesus Lázaro Muñoz. So as the title suggests, we are investigating the interaction of ethylene with the silver exchange chabazite by a combination of inelastic neutron scattering and DFT calculations. So ethylene is a critical feedstock, being the starting chemical for one of the most produced plastics in the world. Basically, during its production, ethylene also coexists with other molecules, such as ethane. So thinking about application, the separation between these molecules is required. However, the current use cryogenic distillation is extremely energy consuming. So among energy efficient alternatives, zeolites are the most promising ones. They are microporous aluminosilicates composed by tetrahedra, forming a 3D framework. There are more than 200 types. And in our project, we're working with chabazite, one of the most important when it comes to catalysts and adsorbents. So the separation by molecular sieving is secondary due to the molecule's similar size, relying mostly on a special selective adsorption called pi complexation, which involves ethylene and a metallic cation allocated in the framework. So our aim here is to shed a light on the investigation for our system, combining a unique set of experimental and theoretical techniques. How? Well, after the synthesis and the routine characterizations of the material, NMR and UVVs are required in order to investigate actually the state of silver species before and after before and after photosynthesis treatments. So if there's the formation of clusters, then EXFs are required in order to evaluate the size and the oxidation of the clusters. And finally, we are also going to probe these materials through inelastic neutron scattering in order to investigate the ethylene's vibrational modes once inside the zeolite. So specific modifications in ethylene's vibrational modes gives us information about the adsorption, activation, and extend. And the data obtained from Lagrange is understood with the aid of DFT calculations. So basically, this is what we've been doing the past year, INS and DFT. And what did we found out so far? Well, actually, that our system is more complex than expected. From UVV spectra in NMR, we found out that there's both species in our samples, cationic silver and charged clusters. So we simulated the interaction of ethylene with both species through DFT calculations, and we obtained a good agreement showing that actually both of our models are validated. Well, through the vibrational mode analysis, we could also interfere that the CC stretching mode suffers a red shift, and there's also the lengthening of CC bonds, indicating that the pi complexation adsorption is activated in our systems. This is also going to be proved by Raman after. But which of the systems are the most favored one? The one with the cation or the one with the cluster? We don't know yet. So electronic density calculations are yet to be run, as well as NMR and UVVs at ITQ and EXFs at ESRF. And I staying at CEPSA is also expected in order to investigate the feasibility of these materials in the industry. And we're also going to analyze the interaction of ethylene with other structures. So thank you very much.